So let's look at the next function to see if it has a whole or vertical asymptote. Again, we're going to have to factor this entire function first because that's the way we can see what cancels out, what doesn't cancel out. So we're going to factor this. I'm going to put it over here. So what multiplies to negative 48 and adds to 2? So that would be x minus 8 and x plus 6. Okay, so now that I have it top and bottom factored, I can find the discontinuity, so I can find the domain restrictions. So, that should be an x minus 8 on the bottom. Okay, so what is my domain restriction? So my domain is all reals, except what can x not equal? X cannot equal 8, because that would cause me to divide by 0. So since that's not in my domain, I know that I have a discontinuity at x equals 8. I just have to decide, is it a whole or is it a vertical asymptote? And so then I look at my function and I say, if I plugged 8 into here, would I get 0 over 0 or would I get a number over 0? Well, when I plug it in, I see that I get 0 over 0. So that means I have a whole, okay? Again, the other thing I could look at is I could say, all right, everything that I have, the factors that cancel out cause wholes, and the factors that don't cancel out cause asymptotes. So anything that is left after I cancel out is an asymptote. Anything that completely cancels out is a whole. Okay? So since these two cancel out, those are a whole. 8 is a whole. So then I know that this original function behaves just like the function x plus 6. This function, if you graphed it, would look just like this, which is a line, but the difference is it would have a whole at x equals 8. So now I need to find out where this whole is. Now remember, since they behave the same, I can put the number into this function right here, and I can get out the y value of the whole. So when I put 8 into there, I get that y equals 14. So I get that I have a whole at 8, 14. And if you graph that function, it's really hard to see holes on a graph. On your graphing calculator, you can, I'll show you how to use that table if you'd like. But if you graphed it, it would have a hole at 8, 14. All right, how do we know if it has a vertical asymptote? So again, vertical asymptotes are going to be any discontinuity that isn't a hole. Anytime that we divide by 0 and it's not a hole, it's going to be a vertical asymptote. So if we look at this first one, we said, all right, what cancels out? We have a discontinuity at x equals 3 and at x equals negative 1/2. We knew this was a whole because it cancels out, right? And then anything that's left over after you cancel out is going to be a vertical asymptote. So this is a vertical asymptote. We also could have figured that out because when we put in negative 1/2, we don't get 0 over 0. One word of caution is if you find something that cancels out and then has one left over, then it can be, and you're like, oh, it's both a whole and an asymptote. It can't be both. So imagine that this function was actually like this. So it has x minus 3 squared. So this x minus 3 cancels out one of the x minus 3's, but we still have an x minus 3 left on the bottom, right? Because it only cancels out one of them. So then I look at this function and I'm like, oh, because it canceled out, it's a whole, but it's also still there, so it's a vertical asymptote. Well, here's what it is. Vertical asymptotes are stronger than wholes. So if you get something where your algebra tells you that there's a whole and a vertical asymptote, you have to use your deduction skills and recognize that it can't be both. And vertical asymptotes are stronger. So if your function tells you that you have a vertical asymptote there, it's going to be a vertical asymptote. Okay? So in this case, vertical asymptotes are anything that is still left over after you cancel it out. So I've canceled everything out, and if I still had something left over, then x equals 3 is not a whole. X is going to be a vertical asymptote. Okay? I hope that makes a little bit of sense. Let's talk just a moment about even and odd. Vertical asymptotes can be even or they can be odd. An even vertical asymptote, if you had a vertical asymptote, let's just say there's an asymptote right here. An even vertical asymptote looks like this. The function is approaching from the same side, or it looks like this. Same thing, functions approaching, like they're both approaching infinity or they're both approaching negative infinity. That's an even vertical asymptote. An odd vertical asymptote, as you might imagine, looks opposite of that. So it looks like this, where they're approaching different ways, or it looks like this. Okay? This is going to be an odd vertical asymptote. How do we know what type of vertical asymptote we have? Well, we look at the function and we look at the power of the factor that created this vertical asymptote, okay? So this factor created this vertical asymptote, okay? Because of this factor, we have a vertical asymptote at x equals negative 1/2, okay? So then we look at the power of this factor, and if the power of this factor is odd, then the vertical asymptote is odd. If the power of the factor is even, the vertical asymptote is even. So in both cases here, our vertical asymptote would be odd, because the power of the factor that created the vertical asymptote is odd. So they would both look like this, or remember, it's possible to look like this. And the only way you would know how to figure out which one it is using limits. And you could use the limit as x approaches the vertical asymptote from the left, and the limit as x approaches the vertical asymptote from the right. So let's take a look at this one. So we factored this one before. Let's see, that was x minus 7 and x plus 2 over x times x plus 2 times x plus 3. Okay, so then we look at it, we see what cancels out. Well, the x plus 2's cancel out, so we knew that we had discontinuities at x equals 0, x equals negative 2, and x equals negative 3. Since the 2's cancel out, that makes that a whole, okay? And then we look, anything left over after we've canceled everything we can is going to be an asymptote. So this is a vertical asymptote and this is a vertical asymptote. And then the question is this an even or odd asymptote? Well, I look at this and I see this has a power of 1, so that makes that an odd asymptote. And then x plus 3 also has a power of 1, so that makes that an odd asymptote. You always look at that after you've canceled anything you can, and that will tell you whether it's an even or odd asymptote. Okay, finally we have this one. X minus 8 over, and this is a little different than the one we looked at before, so it's x plus 6 and x minus 8. And we cancel everything out that we can, okay? So we know we have a discontinuity. Let's start there. We have a discontinuity at x equals negative 6, and we have a discontinuity at x equals 8. And then we decide what cancels and what doesn't. Well, x minus 8 cancels, so that makes it a whole. X plus 6 does not cancel, that makes it a vertical asymptote. And then it's odd because the power of x plus 6 is 1, which is an odd power.